In question number 6, it says triangles LMN and XYZ are congruent. Write a congruent statement comparing the corresponding parts. Then determine which transformations map LMN onto XYZ. Now, I'm going to use patty paper again for this. And it's asking me, how did I get triangles LMN, which is this top left triangle here, onto my other triangle? Well, let's mess around with it for a little bit. If we rotate it, notice how I'm rotating my patty paper. Will it get on the original shape? It will. And now let's go back and count how many turns. Now it's not exact because I didn't, the original shape's actually a little bit bigger than the one on my patty paper. But I'm gonna mark my X and Y axis here. And I'm gonna press my pencil on the origin so that I can count my rotations. Okay, there's my arrow. This is one rotation, 90 degrees. Okay. This is two rotations, 180 degrees. Now, if I make sure my X and Y axis lines up, my vertices do as well. So the transformation is a rotation, 180 degrees. Now, clockwise or counterclockwise doesn't matter because two turns forward, like we just did, is the exact same as two turns backwards. So that would be counterclockwise, one turn, two turns, it matches. Now, I'm gonna move my patty paper slightly, but I'm gonna keep it in the same orientation. Notice how N and Z match up, L and X match up, W and Y match up. That's why it's very important that you label your patty paper so that you can match up the vertices. Now, MN, which goes from down this point up, is the same as YZ, okay? These triangles do not have angle marks, so you can't compare angle marks when matching sides and angles. However, because we were able to map one onto the other, we could just match sides. NL is the same as ZX. ML, which is down at the point to the top corner, is the same as YX. Now, angle M matches angle Y down at the bottom. Excuse me. Angle N, which is the top left corner, matches angle Z. And angle L, which is the top right corner, matches angle X. Oh, and then my transformation, what did I do? That was 180 degrees rotation. Now, could we have done any reflections instead? Could we have reflected it over the X-axis and then translated it? No, it would not match up. But if we flipped it over the X-axis, which would give me this shape right here, and then actually flipped that over my Y-axis, it would match up as well. So two reflections, one over the X-axis followed by the one over the Y-axis, would match a 180 degree rotation. And now, if we just quickly look at number 7, it does say in the quilt shown, triangle RST is congruent to triangle RWX. What is the measure of angle STR? Now, when you're given notation that's similar to this, the middle letter is the angle that we're talking about. So angle STR, if I look over in my picture right here, STR is talking about angle T right there. Now, based on my congruent statement, angle T, which is the last letter in my statement, is going to be the exact same measure as angle X. Now, if I look down here, angle X is 62 degrees. So angle X is equal to angle T, which is 62 degrees. So when you're given congruent statements, you just want to match up the letters that correspond with each other, and those are also going to be congruent. Same with side lengths. Notice how if I take R and T, which is the first and last letter of my congruent statement, RT is going to match up with RX. So where's R? RT, which is this diagonal here, is going to match up with RX. x.